Usually when we talk about diagnosing a problem, there is this expectation of sheer precision.
Right.
Like if a structural engineer is looking at a cracked foundation, they can point to the exact stress point. Or you break your arm, the x-ray shows a jagged white line, and the doctor just points and says, there it is.
Exactly. It's a binary state, like it's broken or not broken. You can physically see the failure point right there.
Right. But then you step into the world of modern enterprise IT infrastructure, and suddenly that x-ray machine is just, well, it's useless.
Oh, totally.
We are looking at a diagnostic landscape that is incredibly murky. You have storage arrays, compute nodes, complex networking, and it's all just tangled up across these hybrid cloud environments.
Yeah, it's a mess.
So when an application suddenly slows to a crawl, finding the root cause isn't as simple as looking for a jagged white line.
It is the absolute definition of diagnostic muddy waters.
Yeah.
And if you're an IT professional, architecting or maintaining these systems, misdiagnosing a bottleneck or over-provisioning hardware to compensate for an unseen issue, that can literally cost an enterprise millions of dollars.
Which is precisely why we're here today. So, okay, let's unpack this. For you listening right now, your mission today is mastering the key technical concepts and assessment criteria for the HPE0-V27 exam. We are going straight to the sources, the practice questions, their underlying logic, all to decode exactly how Hewlett Packard Enterprise architects these massive resilient solutions.
Yeah, but before we get into the architectural weeds, let's establish the foundation for the HPE0-V27 exam itself, right? Because you need to know what you are walking into.
Absolutely.
So it's a proctored exam. You will have exactly 1 hour and 30 minutes to tackle 50 questions. You need a 63% to pass, and it's available in English, Japanese, or Korean.
And crucially, this deep dive is not going to be us just listing you a list of facts to memorize.
No, definitely not.
This is a step-by-step masterclass in problem-solving logic. We're going to decode the mechanisms behind these technologies, the why and the how, so you are fully equipped to understand this material conceptually.
Exactly, because before an enterprise can build or fix their infrastructure, they need to know exactly what is happening inside it. You have to clear up those muddy waters first.
Right.
So let's start with how HPE assesses and monitors these incredibly complex environments.
Awesome. Let's dive right into question 1. Here's the scenario. A customer is experiencing performance bottlenecks in their virtualized environment and needs a solution that provides cross-stack analytics from storage to virtual machines to proactively identify issues. Which HPE solution provides this capability?
Okay, let's hear the options.
All right, your 4 options are Option A, HPE Compute Ops Management. Option B, HPE Data Services Cloud Console. Option C, HPE GreenLake for block storage. And Option D, HPE InfoSight.
Okay,
So what does this all mean? Like, looking at these, my instinct is to immediately eliminate options A and C.
right, yeah.
Because Compute Ops Management and GreenLake for block storage are essentially infrastructure provisioning and management tools. They aren't fundamentally designed to provide predictive, AI-driven analytics across the entire stack.
That is spot-on logic.
Right.
Yeah, the correct answer here is option D, HPE InfoSight.
Okay.
This question is entirely about testing your knowledge of predictive analytics within the HPE ecosystem. To understand why InfoSight is the answer, you really have to understand the mechanism of cross-stack analytics.
Right, breaking down those silos.
Exactly.
Yeah.
In a traditional setup, you have one tool monitoring your virtual machines, a different tool looking at your network switches, and a third tool looking at your storage arrays. So if there's a bottleneck, you're manually trying to correlate timestamps between 3 different dashboards.
Which is just a nightmare.
A total nightmare.
But InfoSight collects telemetry from the storage, the servers, and the virtual machines simultaneously, right?
Yes, and that it applies machine learning to that global data lake. It detects anomalies by recognizing patterns, so it actually predicts issues before they impact performance.
Oh, wow.
To give you a clear analogy, it's not some mystical IT crystal ball. It operates more like a smart grid for a major city.
Okay, I like that.
Right. A smart grid doesn't just trigger an alarm when the power goes out. It notices that a specific transformer is running 2 degrees too hot and automatically reroutes power before the neighborhood ever drops offline.
That makes the distinction incredibly clear. So option B, Data Services Cloud Console, might help you manage storage, but it isn't acting as that proactive cross-stack AI brain.
Precisely. Only InfoSight fits that strict parameter. So let's keep that analytical mindset for question 5.
All right, you are the consultant for this one. The question reads, you are engaging with a prospect to modernize their aging virtualized data center. You propose using HPE CloudPhysics for the initial assessment. What key insights will this tool provide to help design the new solution? Choose 3.
And this one has a big list, right?
Yeah, here are your 6 options. Option A, detailed physical network topology maps. Option B, right-sizing recommendations for virtual machines. Option C, automated migration scripts for public cloud. Option D, storage performance bottlenecks and latency metrics. Option E, application-level vulnerability scanning. And option F, cost comparisons for migrating workloads to the public cloud.
Okay, lots to unpack. For this scenario, the 3 correct choices are B, D, and F.
B, D, and F.
Got it. Because HPE CloudPhysics is fundamentally an assessment and simulation tool for virtual environments. It works by passively collecting metadata from your existing VMware or Hyper-V environment.
Right.
So for option B, it analyzes historical CPU and memory usage to give right-sizing recommendations for virtual machines, meaning it tells you if you've assigned, way too much RAM to a server that doesn't need it.
Which saves money. And for option D, it's looking at storage performance bottlenecks and latency metrics. So it's essentially auditing the input-output operations of your existing disks.
Exactly. And the most interesting mechanism is how it achieves option F, which is providing cost comparisons for migrating workloads to the public cloud.
How does it do that without actually migrating them?
CloudPhysics actually pulls in the live pricing APIs from AWS, Azure, and Google Cloud.
Oh, wow.
Yeah, it takes your right-sized on-premises workload profile and simulates exactly what it would cost to run that specific workload in the public cloud down to the penny.
That fundamentally explains why the other options are completely wrong then. If it's a passive data collection and simulation engine, it is definitely not taking action.
Exactly.
So it is not writing automated migration scripts like option C suggests. It's not scanning for application vulnerabilities like a security tool, which eliminates option E. And it doesn't map physical layer 2 switch connections, which knocks out option A.
Exactly right. You are identifying the boundaries of the tool. Now that the virtual environment has been analyzed and optimized, the conversation has to shift to the hardware. How do we build the physical foundation to support these modern workloads?
Right. We are moving from the blueprints to the steel beams. Let's look at question 2. Which components are integral to establishing a composable fabric and management plane within an HPE Synergy frame? Choose 3.
Okay.
The 6 options are option A, HPE Synergy Composer, option B, HPE Virtual Connect SE, option C, HPE Synergy Image Streamer, option D, HPE Aruba CX, option E, HPE Synergy Frame Link Module, and option F, HPE ProLiant Microserver.
What's fascinating here is the underlying concept of composable infrastructure.
Right.
Because historically, a server was a fixed box of compute, storage, and networking. Composable infrastructure treats all of that as fluid resource pools that can be assembled on the fly via code.
Which is huge.
To build that core fabric and intelligence layer in HPE Synergy, you need 3 very specific components. The correct answers are A, C, and E.
Okay, I want to break down exactly how these 3 work together. So option A is the Synergy Composer. That's the management appliance, right? It gives you the API control to actually orchestrate those resource pools.
Correct. And then option E, the Frame Link module, is the physical connective tissue. It interconnects multiple Synergy frames and enables that unified management plane to communicate across racks of hardware.
Got it.
But option C, the image streamer, is where the real magic happens. It handles OS deployment and what we call stateless provisioning.
Okay, let's define stateless provisioning for a second, because that's a pretty dense term.
Absolutely. Think of traditional servers. The operating system is installed directly onto a hard drive sitting inside that physical metal box.
Right, the hardware has an identity.
Exactly. But with stateless provisioning, the physical hardware is just a blank, dumb resource. The image streamer holds the operating system, the drivers, and the server profile.
Oh, I see.
When a comport node boots up, the image streamer injects that personality into the blank hardware over the network in seconds. If the physical node dies, you just boot up a different blank node with that same profile, and you are instantly back online.
Wait, why wouldn't a standard server component like a ProLiant microserver or Virtual Connect be the answer, though?
Well, because Synergy is specifically about a unified fabric and management plane. A ProLiant microserver, option F, is just a standalone small business server. It doesn't have that composable intelligence.
Right, okay.
And options B and D, Virtual Connect, and Aruba CX, while they are valid networking components that might move traffic within or out of the enclosure, they are not the foundational management brains of the composable fabric itself.
That is incredibly powerful. And understanding that intelligence layer makes it clear why those standalone alternatives are wrong.
Exactly. So let's scale this up. What happens when an enterprise needs the benefits of hyperconvergence? but their growth isn't symmetrical.
That leads perfectly into question 6. An enterprise needs to expand their existing HPE Nimble Storage dHCI environment because their compute demands have grown significantly, but their storage capacity is still sufficient. How should this upgrade be designed?
Okay, 4 options for this one.
Right. Option A. Add a matched pair of storage controllers and compute nodes simultaneously. Option B. Upgrade the storage array controllers to support additional external servers. Option C. Add new HPE ProLiant servers to the cluster independently without adding storage. And option D. Deploy an expansion shelf to the existing storage array to unlock compute capacity.
The correct path here is option C. Add new HPE ProLiant servers to the cluster independently without adding storage.
Okay.
This specifically tests your understanding of the D in dHCI, which stands for Disaggregated Hyperconverged Infrastructure.
Right, because traditional hyperconverged infrastructure, or HCI, was a huge breakthrough, but it came with a historical headache.
You really did.
If you ran out of processing power but still had terabytes of free storage, traditional HCI often forced you to buy a brand new node that contained both compute and storage. It's like dropping a much bigger engine into your car, but the dealership forces you to buy a larger trunk at the exact same time, even if yours is completely empty.
That is the perfect analogy. You are forced to pay for resources you don't need just to scale.
It's exact.
HPE Nimble Storage dHCI solves this by disaggregating or separating the compute and storage scaling. Because the prompt explicitly states that storage capacity is still sufficient, options A, B, and D are inherently wrong because they force the customer into unnecessary storage upgrades or expansions. Only option C takes advantage of the disaggregated architecture.
Makes total sense. Let's push the hardware demands even further with question 10. A customer is planning to consolidate multiple, massive, mission-critical in-memory SAP HANA databases onto a single platform to simplify licensing and management. They require extreme fault tolerance and scalability. Which compute platform should be positioned?
Okay, let's hear them.
The options are option A, HPE ProLiant DL380 Gen 11, option B, HPE Synergy 480 Gen 10 Plus, option C, HPE Superdome Flex, and option D, HPE Edgeline. I'm looking at the phrase massive, mission-critical, in-memory SAP HANA databases. In-memory means it's running entirely in RAM for speed, which requires an astronomical amount of memory, right?
You've hit on the exact mechanism there. For that extreme requirement, the only correct answer is option C, HPE Superdome Flex.
Okay.
When you are dealing with massive in-memory databases, you can't just string a bunch of standard servers together in a cluster. The latency of data traveling between standard independent servers would destroy the performance of the database. You need a massive scale-up architecture, not scale-out.
Wait, so Superdome Flex essentially acts as one giant continuous brain.
Exactly. It uses a unique shared memory architecture that can scale up to an immense number of processors and terabytes of RAM within a single system image.
Wow.
Furthermore, its fault tolerance is handled at the firmware level. It can isolate failing components before they crash the operating system. Options A, B, and D, ProLiant, Synergy, and Edgeline are fantastic platforms, but they rely on standard dual-socket or quad-socket architectures that fundamentally hit a ceiling.
Right.
They fall completely short of the massive scale-up resilience required by these specific SAP HANA workloads.
So we've built this massive fault-tolerant compute engine, but an engine of that size generates a torrential downpour of unstructured data. How do you keep that data from flooding the system, and more importantly, how do you protect it?
That brings us to question 8, which focuses on storage architecture.
Right. Your customer is dealing with massive amounts of unstructured data and is evaluating HPE partner solutions. Which scenarios represent ideal use cases for HPE solutions for Qumulo rather than an object storage alternative? Choose 3.
6 options for this one again.
Yeah. Option A, environments requiring high-performance computing for video rendering. Option B, long-term archiving of medical imaging files with compliance holds. Option C, geodispersed exabyte-scale backup repositories. Option D, high-throughput genome sequencing workloads. Option E, real-time analytics requiring native SMB and NFS protocols. Option F, cross-region replication for cloud-native application artifacts.
The correct trio here is A, D, and E.
A, D, and E.
Yeah, and to understand why, we have to clearly define the difference between file storage and object storage. HPE Solutions for Qumulo is a high-performance, scale-out file storage system.
Okay.
File storage organizes data in a strict hierarchy of folders and subfolders, and it relies heavily on file locking mechanisms.
Which is absolutely critical for something like video rendering, option A. Like, if two editors are working on a massive project, the file system needs to lock a frame while one person alters it, otherwise they overwrite each other.
Exactly. The same goes for genome sequencing, option D, which generates rapid sequential reads and writes that demand high performance. And option E explicitly calls out SMB and NFS, which are the fundamental protocols used by file storage over a network.
Object storage, on the other hand, doesn't use a folder hierarchy at all, right? It just drops data into a massive flat pool and attaches a highly detailed metadata tag to it, sort of like an ID badge.
Right. Object storage is built for massive scalability and durability, but it uses an eventual consistency model, which means it is terrible for high-performance file locking.
So how do we eliminate the other choices based on that?
Well, because the prompt asks, what is better suited for Qumulo rather than object storage, we eliminate B, C, and F.
Ah, okay.
Long-term archiving, exabyte-scale backup repositories, and cloud-native artifacts don't need real-time file locking. They just need to be stored cheaply and permanently, making them textbook use cases for object storage instead.
Makes sense. And speaking of backups and protecting your enterprise, let's look at question 4. A financial institution requires a disaster recovery solution for their mission-critical virtual machines that provides continuous data protection with recovery point objectives measured in seconds. Which HPE Alliance or software solution fits this requirement?
Okay, what are the 4 options?
Option A, Commvault. Option B, Zerto. Option C, HPE Store Once. And option D, Cohesity. Now, looking at these options, Commvault, Store Once, and Cohesity are all highly respected, robust backup solutions.
They absolutely are.
But they usually rely on taking snapshots, right? Like you take a snapshot every few hours or maybe once a day. If your system goes down, you lose everything since the last snapshot.
That is the crucial distinction. A snapshot literally stuns the virtual machine for a fraction of a second to copy its state.
Yeah.
You cannot take a snapshot every 3 seconds without grinding the server to an absolute halt.
Right.
Therefore, options A, C, and D cannot meet the strict parameter of recovery point objectives measured in seconds. The correct answer is option B, Zerto.
Because Zerto uses a completely different mechanism, right?
Yeah.
Continuous data protection via journal-based recovery?
Precisely. Instead of taking snapshots, Zerto places an I/O filter inside the hypervisor. Every single time a virtual machine tries to write data to the disk, Zerto intercepts a copy of that write command and logs it in continuous journal, much like an accountant's ledger, and sends it to the disaster recovery site.
Oh, wow.
Because it's continuously recording the stream of writes, if a ransomware attack hits at exactly 2:04 p.m. in 15 seconds, you can rewind the journal and restore the entire environment to 2:04 p.m. in 14 seconds.
That completely eliminates the data loss window. That's
So.
amazing. Okay, so we have the hardware, the analytics, and the deep data protection. But implementing this globally brings up a massive operational question. How does an enterprise manage and pay for all of this physical gear without locking up millions in capital?
Right.
That introduces the hybrid cloud service model.
Exactly, bringing the cloud consumption experience to on-premises hardware.
Here is question 9. When designing an HPE GreenLake solution, the customer is concerned about sudden spikes in workload demands and how that impacts their billing. How does the HPE GreenLake model handle these unexpected capacity spikes? Option A, capacity must be manually requested and provisioned before the spike can be accommodated. Option B, spikes are absorbed by the local buffer capacity and billed on a pay-per-use basis for that month. Option C, spikes exceeding the reserve capacity are automatically migrated to a public cloud provider. And option D, the minimum reserve is permanently increased to match the highest recorded capacity spike.
The correct answer here is option B. Spikes are absorbed by the local buffer capacity and billed on a pay-per-use basis.
Okay.
If we connect this to the bigger picture to really grasp the GreenLake model, you have to realize HPE installs more physical hardware in your data center than you currently need. You commit to a minimum baseline of usage, but there is always a physical buffer of unlit servers and storage sitting right there in your racks.
Oh, I see. It is essentially like having a VIP room reserved at a restaurant.
Yes.
The buffer capacity, the empty tables are already sitting there on premises. You don't have to call ahead and wait for them to build a new room, but you only pay for that extra space if your party suddenly gets huge and spills over into it.
I think that's a brilliant way to visualize it. And that logic completely invalidates the other options.
How so?
Well, option A is incorrect because the hardware is already physically installed and metered. No manual provisioning is required to handle the spike.
Right.
Option C is wrong because GreenLake operates on-premises or in a colocation. It doesn't force your workloads out into a public cloud like AWS or Azure just because you spiked.
Ah, yeah.
And option D is false because the whole point of cloud economics is elasticity. If you have a temporary spike for Black Friday, your permanent baseline reserve doesn't permanently increase for the rest of the year. You just pay for the overage during that specific month.
That makes a lot of sense. Let's dig deeper into the operational boundaries of GreenLake with question 3. Under the shared responsibility model for HPE GreenLake for private cloud enterprise, which operational task is strictly the responsibility of Hewlett Packard Enterprise?
Okay, let's hear the tasks.
Option A, maintaining physical infrastructure, compliance, and security. Option B, applying application-level security patches. Option C, defining user access policies for virtual machines. And option D, managing the guest operating system lifecycle.
This is a classic boundary question. In a fully managed service, you have to draw a hard line where the vendor's job ends and the customer's job begins.
Right.
The correct answer is option A. HPE is responsible for maintaining physical infrastructure, compliance, and security. That means HPE manages the hardware, updates the firmware, monitors the physical health of the disks, and maintains the base virtualization layer.
So HPE takes care of the physical foundation, basically keeping the engine running.
Right, and the source explicitly dictates that the customer retains responsibility for the higher layers of the stack. This is vital for security and privacy.
Yeah, that makes sense.
I mean, HPE doesn't want access to your proprietary data. Therefore, the customer is strictly responsible for option B, the applications, option C, who gets to access those virtual machines, and option D, managing the guest operating systems like patching Windows or Linux.
That clear separation of duties totally prevents massive security liabilities.
Okay, our final question of the day. Let's pull the camera back and look at how an enterprise manages these connections across a massive physical footprint.
Awesome, let's do it.
Question 7. Your client is designing a smart campus and needs a centralized platform to manage wired, wireless, and wide area network infrastructure across multiple distributed locations. Which HPE solution should you recommend?
Okay.
Option A, HPE Aruba Networking Central. Option B, HPE GreenLake for compute ops management. Option C, HPE OneView. And option D, HPE GreenLake Central.
The answer here is option A, HPE Aruba Networking Central.
A smart campus is incredibly complex. You have thousands of IoT devices, employee laptops moving between buildings, and branch offices connecting over wide area networks, or WAN. Aruba Central provides a single, cloud-based interface to manage all of that telemetry, apply security policies, and monitor network health across the entire distributed footprint.
So it takes the chaos of physical switches, wireless access points, and branch gateways and just unifies them into a single management pane.
Exactly. And to be clear on why the others fall short, options B and C, Compute Ops Management and OneView, are designed to manage server infrastructure and compute nodes.
Right. They aren't network focused.
Exactly. They are not dedicated platforms for campus-wide network routing and wireless management. And option D, GreenLake Central, is the overarching portal for your hybrid cloud consumption and billing. It is not the granular operational tool used to manage switch configurations and Wi-Fi access points.
Well, thank you for joining us on this deep dive. Keep exploring these architectural concepts. Trust your logic as you break down these exam questions, and we'll catch you on the next one.